Dear friends, welcome to a personalized episode of Enlighten. Today we will explore how machine learning and deep learning are revolutionizing technology, delve into the mission-driven strategies of companies like Amazon and SpaceX, and uncover how Apple uses Cassandra and FoundationDB to power iCloud's CloudKit. Stay tuned for an insightful discussion. What's the difference between deep learning and machine learning? To answer this, we need to understand that machine learning involves computers learning from data using algorithms to perform tasks without explicit programming. This means the computer recognizes patterns and makes predictions based on the given data. For example, if you want to predict your income based on your years of higher education, you can use a simple, linear regression algorithm. You'd provide data on people's education and income, and the algorithm would find the pattern and make predictions on new data. This process can be supervised, where the algorithm learns from labeled data, or unsupervised, where it finds patterns in unlabeled data. Now, deep learning is a specific subset of machine learning. It uses complex structures called artificial neural networks, inspired by the human brain. These networks consist of layers of algorithms that process data in a way similar to how humans conclude. For instance, in self-driving cars, deep learning helps the car recognize objects like stop signs or pedestrians. The network learns from images or videos and adjusts its predictions based on its errors, requiring minimal human intervention. One reason deep learning has gained traction recently is the availability of vast amounts of data and increased computing power. Cloud computing and high-performance GPUs have significantly reduced the time needed to train these networks. Another important development is transfer learning, where pre-trained models are used, reducing the need for large datasets. In summary, while machine learning involves computers learning from data, deep learning takes it further with sophisticated neural networks that require less human intervention and more data. The main takeaway is that deep learning is a specialized form of machine learning that leverages neural networks to perform complex tasks with high accuracy. Now, let's talk about how mission-driven companies like Amazon and Google prioritize their vision over short-term gains to achieve long-term benefits. Why do some of the most successful companies seem to focus more on their mission than purely financial goals? One explanation is that a mission-driven approach can create unique advantages. Companies often start with a clear mission, but as they grow, their decisions are influenced by external factors like suppliers and customers. This external influence can shape their business more than their initial vision. However, there are exceptions where companies stay true to their mission, even if it means sacrificing short-term profits. Take Amazon, for example. When they launched their EC2 service, they initially planned to rent servers for 15 cents an hour. At the last minute, Jeff Bezos changed it to 10 cents an hour, effectively making it a loss-leading service. This decision aligned with Amazon's broader mission to offer affordable solutions and figure out profitability later. Similarly, Google launched services like Google News and Google Books with no clear business model, but aligned them with their mission to organize the world's information. A mission-driven company often faces more variance because it might stick to its mission even when it's not immediately profitable. For example, a company focused on free speech might allow content that others would ban, attracting a particular user base and the associated challenges. Telegram's founder, Pavel Durov, faced legal issues because of moderation policies on the app, something more reactive companies might avoid. But sticking to a mission can also create significant upside. Companies that combine mission with regular business practices often attract better talent and innovative projects. For instance, Intel kept developing advanced chips ahead of software needs to dominate future markets. Amazon's mix of mature and emerging revenue streams, and Meta's willingness to launch unmonetized products show how mission focus can lead to long-term gains. Mission-driven businesses often act as shock absorbers in the economy, absorbing financial hits to stay true to their goals. SpaceX, for instance, might report losses while pursuing its goal of making humanity a multi-planetary species, whereas Boeing might adjust its expectations to remain profitable. This makes mission-driven companies bigger bets with potentially lower expected financial returns, but higher social or strategic value. Investors who care about missions might still support these companies because they align with their values. And sometimes, industries dominated by idealistic founders, like tech, show exceptional returns by doing things differently. Nucor, a steel company, is an example of success through tactical adeptness rather than a grand vision. In summary, while focusing on a mission introduces variability and challenges, it can also create unique opportunities and attract better resources, leading to significant long-term benefits. Now, let's look at how Apple leverages Cassandra and FoundationDB to enhance iCloud's Cloud Kit for handling massive data and high concurrency. How did Apple build iCloud to store billions of databases? Apple leverages two powerful technologies, Cassandra and FoundationDB for CloudKit, its cloud backend service. These tools help manage their extreme multi-tenant architecture, where each user of each application gets independent record stores. Cassandra is a wide-column NoSQL database system, initially developed at Facebook. Apple runs one of the largest Cassandra deployments in the world, managing hundreds of petabytes of data with millions of queries per second. However, Cassandra had limitations. Within a single zone, only one operation can occur at a time, and updates to multiple records simultaneously in an atomic operation are limited to a single partition. These challenges prompted Apple to adopt FoundationDB. FoundationDB is a distributed, transactional key-value store designed for large data volumes and high concurrency. It's ACID compliant, ensuring reliable transactions. Apple uses the FoundationDB record layer extensively for CloudKit. This layer serves as a relational database on top of FoundationDB, featuring structured types, multiple index types, and support for complex queries. The combination of FoundationDB and the record layer solves several key problems. First, personalized full-text search. FoundationDB allows for efficient search without extra overhead, updating the search index in real time as data changes. Second, high concurrency zones. FoundationDB handles many updates simultaneously by using unique version numbers for changes, avoiding conflicts that were problematic with Cassandra. Third, high latency queries. The record layer performs tasks asynchronously, covering up delays by queuing tasks and working on several fronts at once. Fourth, conflicting transactions. FoundationDB allows precise management of transaction conflicts by using snapshot reads and custom indexes to handle conflict ranges efficiently. By combining these technologies, Apple supports extreme multi-tenancy at scale, managing billions of independent databases while ensuring reliability and performance. In essence, Apple's use of Cassandra and FoundationDB demonstrates how leveraging the strengths of different systems can overcome specific limitations, resulting in a robust and scalable cloud solution. In this episode, we explored how machine learning, mission-driven company strategies, and Apple's use of advanced databases like Cassandra and FoundationDB drive innovation and reliability. Stay tuned for more updates. Dear friends,